is all the better. We can have, I was going to come in and secure a few guys, but if you want, please join. This is meant to be informal and, and conversational. Yes, it is recording, so it's fine. It should be okay. If you join from where you are, if you want to come closer, that's fine. We'll keep it informal. That's the idea. This worked really well. When we first started this last year, JMed in Seattle, when we had our first session of this type, and it worked so well that people. I mean, our intent was to make it less like other sessions that are more formal. And maybe kids ask a question, maybe that question gets answered, and that's it. But we're all practitioners essentially of the same art. So I think the idea is to share experiences and support one another. I will just start by saying it worked out better than I thought. It's always a challenge to organize a bunch of talks, 21 talks in 3 days, and how do you group them together, right? So, and I didn't have the slides, and you didn't have your slides either. So it was just by the abstract. And I did a little background research in each of you, and I felt that it would work, and I think it worked very well. I think this was the specific sort of focus on teaching and teaching practices. I love the clips. I have some clips of my own in my talk, but I'm not the only one. Noticing, something when I transitioned from teaching at the university many years ago to teaching at the high school level, it changed my life. People never learned. It was never taught me. I was just thrown into a classroom when I was, after my PhD, and when I started teaching for years, I was just, here's what you teach, and so the actual act of teaching as a process, I only started learning years later and noticing what the students do. But teaching isn't about you doing it, but it's an interaction. It's something that happens on the side as well. Was for me essential, and I sensed that this grouping of talks was going to be about that. So I think fun was the running theme here. Yeah, it was fun. Talking about having fun. I mean, in the games. I mean, Nick, I think it was all about fun, and I think the clips showed the students getting excited. What do you feel makes fun relevant for math? I mean, are we just doing it for the students, or is it somehow important in math? Like, what's the interaction between fun and math?
I think it's about incentivizing students to continue persevering through difficult things. Like, if you want students to put in the time it takes to develop a deep appreciation, understanding, then there has to be an element of fun to help them keep returning to the problem.
It's funny, I almost feel it's sad for even asking that question. I'm curious, like, why would we be doing it if it's not fun at some level, fundamentally?
Exactly. But ask anyone on the street, I bet you, 80%. I'm going to be so specific. If you give statistics, it's not more serious, but a large portion of the people you meet at a bar or whatever, if you say this to them, they'll laugh in your face. How can math be fun? Right? I mean, one of the reasons I wanted to do this session was because we have this great resource, right? We collectively as mathematicians get access to essentially, the large portion of the human population for a number of years, formative years of their lives. And the vast majority of those people are left feeling like math isn't for them, in the sense that not only is it just, I'm not going to play the piano, I'm going to play the violin, it's that kind of thing, but more like it's against me. It's the kind of thing I can't imagine being in a place that, it's not talking to me at all, right? I don't understand why people do it. So yeah, if people believe, Andrew, that math is fun, but people that, if you just stop and think, well, why do people do this? Why have people done this for millennia, you know? Is it a domination strategy? Is it some sort of ploy to, you know, run the world? Or is it intrinsically fun?
And then yes, like why aren't our classes fun? If we think math is fun, and if we're enjoying teaching, if we're enjoying math, which maybe we're not often as math teachers, why isn't math class fun?
It depends on what we set as our own goal when we teach. Like if my goal as a teacher is just convey the material and make sure you learn the material, then I have no interest in making it fun. If my goal is to make you discover that this stuff is so cool, then you would probably implicitly, like without even realizing, you will make it more fun.
I used to volunteer in preschool and kindergarten classes and would do mathematics with the students, 4, 5, 6-year-olds. I never encountered a single student in those classes who wasn't excited to enjoy doing math. I think mathematical activity, measuring, counting, comparing, these are fundamental human activities that humans love doing. I haven't found a 5-year-old who doesn't love doing mathematics. It's actually the process of school mathematics in which we beat it out of them so that by the time they get to middle school and above, they think that it's terrible, right? So it's not mathematics itself as a process that isn't fun. It's the ways in which we've codified how to teach mathematics in formal school settings in which the mathematics the students are learning, they are not engaging in those processes of deducing, thinking, creating, conjecturing. They are memorizing procedures that we are teaching them as part of the canon. So it is possible to change the direction of that and shift what we mean by what it means to actually do math. And then I think the fun question would be a completely different one.
I wonder if we have a little bit of a blind spot though when it comes to fun. I have encountered an increasing number of students that don't find games and puzzles fun even if they're not math. And in surveying found an increasing number of students who would rather watch a YouTube video of someone playing a video game than play the video game themselves. And so my notion of fun might be different from the student's notion of fun.
We have found that as well. We spent Rob and I spent like 3 years designing a bunch of tasks that we thought would be playful. And we've done them with a lot of students, and it was just in this past year that we began interviewing students after the fact to sort of ask from their perspective what's actually playful. And you know, this is so obvious in retrospect, but of course the stuff that Rob and I find playful is not necessarily what all kids. There are kids who like puzzling, intriguing things, and it has to be hard to feel playful for them. There are other kids who want to feel safe and be in a community and have their friends help them, and they want it to be structured and scaffolded, exactly the kinds of things that we wouldn't find playful. So I really appreciate that comment because it emphasizes the critical need to actually understand where our students are coming from. And those ones who like to watch the YouTube videos, there's other stuff I think that they will find fun. We just have to figure out what that is and then design for it.
Yeah, I started surveying my students to see why they chose the major, see if I can get some insight into what their values were a little bit more. You know, some of them value service or helping people.
Yes.
Some of them value earning a lot of, a good paycheck one day, or whatever their priorities are, maybe different from the problem-solving mindset that I have.
So, sorry, go ahead.
Well, I wanted to just mention that watching someone play a video game instead of doing it there's something interesting about this. Like, you're still engaging with, like, anticipating what's happening and, like, thinking about how you would do it, but the stakes are really low. Like, you're not actually the one who's gonna, like, have your little guy die or something in the level. I love, like, watching, I love watching my friends, like, play video games and, like, be with them, sometimes more than doing it myself because of that same thing. But that's still, like, pretty different from a math classroom where you're not engaged in those types of anticipatory reasoning and watching a teacher do something, like you're just tuning that entirely. So I wonder if there may be some, like, almost like stimulus level that they're still like, ooh, I'm engaged in the thing, but I don't want to have quite that much intensity in my own activity. But I still want to be like actively engaged. I don't know.
Yeah, so let me give you somewhat outside perspective, since I'm not a Malaysian, I don't teach math, but I don't see in here that I do some.
He was a physicist, so.
Yeah, I'm actually an engineer, but
Oh,
so I don't know what I work. But the point is that I think you're kind of lumping a lot of things together. Like to me, there are some parts of math that are so fun, some other parts that are completely dreadful, that I don't understand what you guys are talking about. And there are other parts that are just the tools that I use for my job. So whether I have different attitude depending on the topic and depending on the task at hand. So I think finding a single common thread, since everybody is going to be different, is kind of difficult.
I do agree with that. So like, in order to be able to access those higher level things that we think are fun, there are some like rote. They like the elementary school have to memorize the times tables. You know, like you have to know how to factor to be able to access like the Calc 1, Calc 2 stuff, or multiply binomials to be able to do all that extension. So there are some like rote things that take repetition. But so I do agree with that statement that there are some things that are more creative and abstract and like things you can play around with, but then at the end of the day, there are some things that I feel like have to, I don't know, be built over time through.
Let me say something. There is, I think, the ability to deal with a certain level of abstraction that I don't even know that it can be taught. So in computer science, there is always this joke, if you do C++, there are people who understand pointers and the people who don't understand pointers. And I had this experience of trying to teach pointers to people, and they just don't, I don't know if anybody went there to explain to someone of this, they just don't get it. And I don't understand whether it's an innate thing, like there is a certain level of abstraction that, I can reach some level, and I when people talk about high level category theory, I get lost. And it's not for lack of trying, I just don't get it. And so,
I've been conducting teaching experiments in my research with mostly middle schoolers and high schoolers for over 20 years now. And I do it every year pretty much, and have yet to find a student unable to learn the kinds of complex, abstract mathematics that I teach them. I do think that it can be exceptionally difficult to accomplish that as a teacher within the constraints under which you have to operate, right? Within the time constraints and the sort of the coverage constraints and the grading constraints. And so the delight of my research is that I operate outside of those constraints. So I have as much time as I need to sort of follow the student's reasoning and support that developing reasoning. I would push back hard on the idea that there's something innate going on here, simply because I've never encountered a single student who cannot develop these ways of reasoning. It's just that the kind of more traditional constraints of schooling, including undergraduate instruction, can make that very difficult for us to support within like a 15-week semester, for instance.
There's so many threads here, and I really don't want to be interrupting the flow. I love the flow. But just to add a component is, in my mind, returning to the idea of fun and whether everyone will see the same thing as fun, I want to perhaps suggest there could be a distinction there. And I use the analogy that my friend Paul Lockhart does with music, between math and music, as an analogy to help make my point. There's certainly a pleasure in playing music, in playing in a small group, for example. Some of us have had that experience. Some people obviously do it for a living. This has happened for millennia, so clearly it's aspect of human nature. But most people don't, for a variety of reasons. Maybe they can't, maybe they don't feel that's important enough in their mind to do. But a much, much larger group of people enjoy listening to it, or being in the room even with those people. And I just make a distinction between those two because potentially there is a difference being in physical space there and seeing the people do it as opposed to also just the pleasure of just listening to it. Anyway, there's a gradation of possible engagement modalities, let's say, with music. Why can't the same thing be true about math? There's the pleasure of actually doing the math. When we've all, I think, experienced that. That's partly why we're here, I think. Is there a kind of analogous enjoyment in seeing the math played out, in seeing the math happen? And clearly, math is different from music. The analogy can only go so far. But fundamentally, how shareable is that pleasure, that fun? How expressive is it in terms other than mathematical? Because presumably, it speaks to human nature in some way, right? It's when we call it fun, we have a notion of what fun is. Fun means a variety of things, including listening to music. Why do we call it fun? What is it that it shares with that, and how can we tap into that shared common human experience? Yeah.
I think the fun really comes from that kind of aha moment when a concept really clicks into place. You have an almost transcendental understanding of it in your own mind. And I think the challenge of that of enjoying math kind of vicariously is I'm a big believer that you can't understand unless you're doing it. And that's, I think, one of the problems with students trying to learn just by watching videos is that they're not engaging with the material at the level required to actually achieve that aha moment, which means it's a fundamentally empty experience. They never actually get to that. The fun, they don't ever actually get to the fun because that comes from
I would add one thing to that, and Jack, you can go, but which is that perhaps it's part of the problem might be partly on the videos themselves, in that the videos don't show the aha moment. It's not someone really discovering something, so that vicarious sense of I'm listening to this, quartet come up with an improvisation or whatever, I can sense their pleasure in doing so. There's not that. It's like I'm reciting some facts, so, but, yeah, Jack.
Yeah, I have a lot of friends who know that I am a math person, and they are always sending me Instagram posts and clips and YouTube videos. Hey, do you see this? Like, this is crazy. And they don't have an aha moment or understand it, but they're interested in it and they think it's cool and they want to share it with me. So I don't think you don't have to play the C chord to appreciate the C chord.
Yeah.
So I guess my question related to that, though, is kind of about the selection bias. You'll have some people that enjoy going to watch an orchestra perform, and you'll have some other people that enjoy performing in the orchestra itself. What are we expecting from our students? Because it seems like, the students in our classes, we want them to be doing some math. And if they're of the mindset that, well, I enjoy watching someone do it, but I don't want to do it myself, is that really meeting our learning outcomes in a class? And if someone chose to be in an orchestra, they didn't always choose to be in our class, right? And so kind of an uphill battle that we have to fight there.
Absolutely. Then back, I'm sorry,
When I was an undergraduate, I took a course called Music Appreciation. I did not learn how to play an instrument, but I learned to appreciate it, right? And that would be very different from being in band classes. Should we divide math into math practice and math appreciation?
Well, I mean, I'll frame it as maybe like an optimization problem, right? Of course, we have to decide what the objective function is. But if we were trying to maximize the probability, let's say, that after the fact, when we randomly select a person and we ask them about what they think about math, they don't have a negative feeling about math, would we be better off trying to get a few of them to really, really know and do math, or more? I mean, what is it that we're trying to get at, really? And we're clearly not getting it, is what I'm saying. We're getting a lot of good math happening by a small, arguably, even though the number of people involved in math is increasing, the rest of the population is increasing faster. So I think that the penetration is probably decreasing, or I'm not sure. But Gabriel, I'm sorry.
No, I wanted to, since I do YouTube videos, so first of all, you have videos that actually give you aha moments, so the fact that you don't have, you have them. And then there is also the pleasure also of looking at somebody doing something which is the best part.
That aha moment, I mean, yeah, it might be fun to watch someone else have it, but it's fun to have it. It's really fun to have it. And you know that little clip we showed of the two girls who clearly had this huge aha moment? We talked to them afterwards, and they and many of our students said similar things. Enzo said that wouldn't have been nearly as satisfying if it had only taken us like 5 or 10 minutes. They had struggled deeply with that problem for 40 minutes. It's actually the epiphany after the struggle that is fun. Without the struggle, it's not really an epiphany. A researcher at UCSD, Prashant Burrell, calls this joyful agony, right? And it is, it's both. The joy happens because of the agony. And you're just not going to get that vicariously. You're not going to get that without doing it.
But like, we're also, I think, something like the analogy between playing music and music appreciation is, there's something about that analogy to what we're talking about that breaks down. Because like, all of our students are doing math. They're doing homework, right? They're doing problems. Like, I don't think any of the classes we're talking about are like akin to a math appreciation class. What we're just talking about is like playing or having fun is like a different kind of doing math. Like, we're not advocating, let's actually have our students do math for the first time. We're advocating a different way of what that means, like what the experience is, because the way that mathematicians engage when they're doing math is so vastly different from the way that students do. Why do we count a math class as being, like, why do we prize the content of the math class and not the experience of doing math as being the thing that, like, wouldn't it be a more accurate math class in some sense if the activity that the students were doing was the same kind of thing that mathematicians were doing, even if the material was completely different, or the content that they learned was different? Would that be like somehow more accurate than like if we had the same material? I don't know, something.
Robert, I mean, you just hit, for me, the nail on the head. This is the experience I had when I transitioned 16 years ago from teaching at the university, teaching at the high school level. And I've had other friends, in this case with my wife, who is teaching chemistry, but many other friends of mine who teach different subjects. And they never told me this. It strikes me that math stands out in schools in exactly this respect. There's no other discipline where what the students do in the class is that different from what you would do as a professional. I mean, yes, the topic, the content is simplified, and there's more protection perhaps and all of that. But in math, no working mathematician does the stuff that we have them do in a traditional class. I mean, okay, in chemistry they do simpler experiments and maybe you guide them and so on. I'm just saying, maybe I'm overstressing the analogy, but for me, this was revelatory. It never occurred to me before, and I wanted to change that. I really wanted to spend, and that's what I've spent the last 15 years, is changing that and foregrounding more the experience of math in the math classroom rather than any content. That the content, what they get, will be up to them, basically. If math, like, who am I to speak on behalf of math? Math is what it is. If you get to engage with it in the ways that mathematicians developed over millennia, again, there's some truth to that, then they'll get something out of it. What they get, I'm not there. My job isn't to tell them what they're going to get out of it. So, yeah.
Can I strongly push back on that? Because
Please.
physics is the same.
That's the best.
In fact, there are a lot of people that start a PhD and they realize that what I've been doing is completely different from research of physics, and then they drop out. You can find a lot of YouTube videos of people that went through the process. So it's the same with physics. And what people do is not research, it's just solving problem there.
And I'd add to that, I think it's our fault. I think it's mathematicians' fault, in the sense that physics classes often become essentially like math classes. In other words, what I mean to say, there's physical intuition a la Feynman, you know, how Feynman tried to appeal, much of his writing and his talks and his lectures was to appeal to physical intuition, why you think something must be right, before having the math, before having any formalism for it. We don't teach physics that way. By and large, I mean, I'm not a professor of physics, I've taken many physics classes and love physics, but I think for the wrong reason in some sense. You know, I don't have necessarily physical intuition, I approach it as a mathematician, as a, you know, but I think I can say that because I'm a mathematician, right, rather than just a math student subject to being taught how to think. I've managed to escape that. Most students don't escape that, and then when they encounter the need to actually do physics, they're not prepared. That's not what they signed up for.
Let me push back, I'm sorry. First of all, like the majority of people who study physics, they're not going to do research in physics. Like they're going to do everything. So if you just cater to the people who are doing the research, like 95% of the people that are studying physics, they will not research. Developing the physical intuition for solving problems is still different than developing the physical intuition to do research. So to create, to understand what it means to find different things and extend. There are different skills. Like it's you. There are two different skills. And it's fine that they're different, and it's fine that when you're teaching, you're caring to 95% and not 5%. Maybe you can have other classes in which you teach. I think in mathematics is a little bit more similar actually than the activity. Like I think you can set up the type of things that you do because you're just looking at different structures, like a less complicated structure, and you can have that playfulness. In physics, you don't. You can't really what you do. Like you do it in a lab, like you do these experiences, but it's not the same as go ahead and develop your own experiment to try to figure out what, if there is a law for the ideal gas, because you don't even know that.
If I can connect with what you just said. So I see that in our classes we have a certain issue of being inclusive and being selective. So mathematical talent is very selective, incredibly selective. But in our classes, we're trying to be inclusive. So we are providing some kind of feedback to students. It's very one-dimensional feedback, just one number. But then, what do those people do with that feedback? And it plays with what you said, that with the feedback that people receive, they thought they were good at physics.
Yes.
Or in mathematics. They thought that they go to graduate school, like, no, I cannot do anything with that A that I had all my life. So what is wrong with the feedback? I think the feedback we are giving is just too plain to fulfill the needs of, well, administrators, just fine. They just need to know who is smart enough to continue. But for our purpose, to select talent, mathematical talent, and be able to polish it over years, we need additional feedback, at least two numbers. Be continuous.
I'd like to thank everyone in the interest of time. I don't want us to run over. Clearly, and that's a feature, not a bug, we're leaving this with more questions than answers, but I think perhaps slightly better formulated questions. Thank you.
Can I ask one more, just not expecting an answer?
Yeah.
So someone who's new to this conversation, this exploration, I have a meta question, right? So we're trying to reshape attitudes so that we're not just sorting out students or distancing students or saying, well, they're not going to get it or whatever. How do we put these kinds of things into practice to bring other colleagues into the conversation, right? So we're self-selecting by choosing to be here. So if we have colleagues who are resistant or dismissive, and we're trying to bring them into a similar attitude, how do we do that in an engaging and inviting way in the same way we're trying to help our students?
Thank you for that question. It's a hard question. But I can tell you this session is bigger than the session we had in Seattle, which was the first one. That was bigger than we expected. We had 14 speakers, and there were about 40 people, and it was almost a whole day. And this time we had a second session tomorrow. 21 speakers, so it's happening, but it's happening slowly. Yeah.